Good everyone, welcome to Tutors once again. Yeah, today we're going to continue on our calculus series, an differential series. I'm going to look at maxima and minima. Hmm. What is maxima and what is minima? Okay, they are points and they are called turning points. Turning points. Have you ever plotted some graphs and you can see that you have to use probably a French curve. In some places they use like broom to just make sure that it curves the points that you plot on the graph, and you want to form a curve. Okay, people use French curve for that, and you plot the curve. You have the maxima, you have the minimum. Good. So maximum point. Okay, the maximum point is the maximum value of y. Okay, maximum value of y. Okay, and minimum point is the least value of y. Least value of y. Good. So first, questions may come in this manner or direction where you are being required to find a turning point. Turning point. So a turning point refers to both your maximum and minimum point. Okay. Yeah. And in the steps that I will soon list, you can also be able to find also what we know as the point of inflection. Point of inflection. So let me briefly define what point of inflection means. So a point of inflection, as known as a point, is the point where the concavity, where the concavity of a curve changes. Changes. Okay. So you have something like you have curves like this. Okay, curves like this. These are how polynomials with point of inflection looks like. Okay, their curves are just looking like this kind of format. So good and good. So first off, the first thing to first determine first is that the steps to determine a turning point. The steps to determine a turning point. So number one, steps to determine a turning point. Number one, for any polynomials. For any polynomials. If you are given the function y equals to a function of x, you find what? Find the y dx immediately. After finding the y dx, step 2, set the y dx equals to 0. Set the y dx equals to 0 and solve for x in the equation. And solve for x in the equation. Good. Number 3, the value of x obtained in step 2 are to be substituted, are to be substituted in the original function y equals to fx to get variable y, So, and this is referred to as the turning or stationary point. Referred to what? The turning or stationary point. So it depends on what you get. If, for example, you are solving a cubic equation, if y is equal to a cubic equation, if you differentiate it, you get a quadratic equation. Good. Which means that when you're solving for x here, you have two x1, x2. Okay? But if what you have there is a quadratic equation at first, your dy dx will just give you a linear equation. You only have only one function of y. So, but if it's a quadratic equation, your stationary point will be 2, where you have x1. If you substitute x1 inside this function of x, you have x1 comma y1, and substitute x2 inside this, you have x2 comma y2. These are your stationary points. But if it's only one and substitute inside that one, you just have x comma y. Good. Then good. That's 1 to 3 for that. Now let's move to 4. Good. So the fourth is how to know or how to determine. To determine the maximum. Now we have stationary points. Determine the maximum, which one of them is maximum and which of them is minimum point. Okay. You differentiate again, which is you find the square y over the x square. Find what? The square y over the x square. And substitute the value of x inside it. And substitute the value of x. The value of x inside it. Okay? You find the square y over the x square, substitute value of x inside it. Good. Then the fifth is what will, these are conditions. Now, if the square y over the x square, after substituting the values, is greater than 0, it means that at x is equals to xi, it means that it is a minimum point. It is a what? Minimum point. If the square y over the x square is less than 0 at x equals to xi, that means I can take the first x1, I can be 1 or 2, anyone. So that is xi. So when you substitute that value, okay, any x value that you substitute inside it, so you get a minimum point. So don't worry, we'll solve the question and get there. If less than 0, it is a maximum point. Okay, so me, I don't like confusing myself. So a very easy way to get about is that immediately you get the square y over the x square. If it's greater than 0, just take your mind opposite. Greater than 0, opposite, minimum, opposite. The square over the x square, less than 0, opposite, maximum. So you know that. Less than 0, opposite, maximum point. Greater than 0, opposite, minimum point. That's my own app. Okay, so, but if you have the square y over the x square exactly equal to 0 at x equals to xi, it is neither a minimum or maximum point. It is known as what? It is a point of inflection. It's a point of what? Inflection. Good. Let's finally move into questions. So we look at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Good. So now, first question. They and find and classify, find and classify the stationary point, the stationary point of the curve, stationary point of the curve. Y is equals to s cubed minus 3s squared minus 9x plus 2. Good. The first step says you want to find the stationary point and it says you should classify the stationary point. So any point you get, you have to classify them. What are the classification? Is it a minimum? Is it a maximum? Is it a point of inflection? Good. Okay, so let's start. So the first step, you find what? The first step says if y is a function of x, find the what the y dx. So let's differentiate this guy. First step, find the y dx. So the y dx is equals to 3s squared minus, we're differentiating each of these guys, okay? Minus 6x minus 9, okay? Second, say we should set the y dx to equals to 0. What's our y dx? 3s squared minus 6x minus 9 is equals to 0. So we can divide all through by 3. We have s squared minus 2x minus 3 equals to 0. Okay. Then we have x plus 1. Okay. So s squared minus 3x plus x minus 3 equals to 0. So you can avoid all of this by using your calculator to get there are calculators that can solve quadratic equation easily. So x minus 3 plus 1 x minus 3 equals to 0. So you find the root of the equation. That's just the goal. Just get the root of the equation with your calculator and you'll be fine. So we have that x plus 1 is equals to 0 or x minus 3 is equals to 0. We have x is equals to minus 1 or 3. Good. We've gotten our x1 and x2. Good. The next step, step 3, says what? I still say the value of x obtained in step 2 are to be substituted in the original function y equals to function of x to get variable y. Are to be substituted in the original function y equals to x. Okay, so substitute inside the original function. So what's the original function? S cubed minus 3s squared. So y at when x is equals to minus 1. So anywhere you see x cubed minus 1. So minus 1 cubed minus 3. This is what I'm doing. This function, the original function. So we are substituting the first root, first x minus 1 inside it. Plus 3 bracket minus 1 all squared minus 9 minus 1 plus 2. Give us minus 1 minus 3 give us 1. Minus 1 squared is 1. Minus 9 times minus plus 9 plus 2. That gives us minus 1 minus 3 plus 11. And that gives us 7. Okay? So which means our first point is what? Minus 1 and what? 7. Now our second point will be what is y when x is equals to what? 3. We have 3 cubed minus 3 open bracket 3 squared minus 9 open bracket 3 plus 2. So press the calculator, you get what? Minus 25. So get our second equation is what? 3 comma what? Minus 25. These are what we know as what? So our stationary point is now what? Minus 1 comma 7 and what? 3 comma minus 25. Good. So which is our maximum, which is our what? Minimum. Which is our maximum, which is our minimum. Good. At this point here, I can actually get my maximum by just knowing that what I told you what's the definition of maximum point I defined. I told you clearly that maximum point is the maximum value of y. Maximum point is the least, minimum point is the least value of y. So I just look at both equations. I know that this x1, y1, x2, y2. So between y1 and y2, which one is higher, which one is lower? I know that this is my maximum point. I know that this is my minimum point. So good. I can get it here without not the square y over the x square. But let's move on into the fifth step. Okay, so the first step is that what differentiate our dy dx, okay, further, which is get the square y over the s squared. That gives us what 6x minus 6. Okay, 6 minus 6. And the fifth says that what substitute the value of what x that you get inside this equation. Okay, so the square y over 6s squared over no over the s squared, square over the s squared at x is equals to what minus 1 will give us what, so 6 over bracket minus 1 minus 6, that gives us what minus 12. Okay, minus 12. So this means that what the square y over what ds square is less than 0. What do I say about this? Think opposite. If less than 0, if your the square y over ds square is less than 0, what do you have? Is the maximum point. All this is just telling you about maximum point, or minimum point, or maximum point. So let's do the other one. The square y over the s square at x equals to 3. So that gives us 6 over bracket 3 minus 6. That's 18 minus 6, and that's what 12. And it means that the square y over the s square is greater than 0. Think about the opposite. Greater than 0, greater, minimum point. So you can finally reach here before you determine, or you can just take it into my arc and stop at level 3. But it might not really help. So many a times good to reach the fifth level because of point of inflection. Okay, so sometimes you might not have just maximum minimum, you might just have only one point and you have to apply point of inflection into it. So we've finally come to the end of the video. Thank you very much, and kindly comment and give us a request for videos that you like to be treated and covered by GeoTutors. Thank you everyone for watching. God bless.